Oh, yeah. What's up, everybody? Welcome to the Artist of Data Science Open Office Hours. It is Friday, the 13th. Friday, November 13th. A Friday the 13th in the year 2020. Can things get worse? Man, it has been a interesting week at the Artist of Data Science. We had some awesome stuff happen this week. Earlier this week, I released an episode with Sadie St. Lawrence. Go check that episode out. That was amazing. I've done interviews this week with some awesome people, Robert Greene being one of them. I've also interviewed with Kevin Zollman, C. Ann Lewis. I was supposed to interview Chase Caprio of Impact Theory today. However, we had to reschedule to Wednesday. And oh my God, it is the godfather of data science himself, Dr. Thomas Ives is in the house.
Oh, I don't know about man. That makes me sound like a mafia king. Thank you very much.
Hey, we can start our own mafia, Tom. How are you doing, man? Thank you so much for swinging by, man. I'm happy to see you.
Oh, I was actually kind of looking forward to this all day, and was really rejoicing with you about your accolades you appropriately received from Robert Greene earlier. That was
Oh,
great.
thank you so much. Yeah, that meant a lot for me. To have that recognition for the amount of effort I put into my interviews, like preparing for interviews, like it genuinely like it kills me, it drains me because I spent the last 2 months rereading all of his books, and the same goes actually for everybody who comes on my show. I spend at least 12 to 15 hours researching the person,
Oh,
whether they're even if they're just a data scientist like myself. I tend to go for data scientists who have blogs or contents that I could at least go through and pick out things to talk about. So, if it's just a data scientist, I mean, I don't mean to say just a data scientist, but if it's a data scientist, I'll go through all of their blog, all of their content, read everything that I possibly could, and pull out questions. And it becomes doubly hard when they're authors who've written multiple books, to go through and just come up with questions and, listen to every interview podcast that they've been on and try to tease out, okay, these are questions that they are always asked. So I'm not going to ask those things and try to find something unique to come up with.
there's only one thing not dangerous about you just giving the secret away to why your shows are so good. And
Here's
that is, well, let me explain.
yeah, yeah.
Reason you're not in danger for giving your secret away is because you put so much obvious effort into the depth of your interviews. No one's going to work that hard like you were doing.
Exactly. I was just going to say that, right? I can give the secrets away to everyone, but I don't know if everybody's necessarily going to be putting in all of the work. And oh my gosh, we got another amazing person right
David.
here. We got David Knickerbocker in the house. Man, this is a jam-packed episode. We've also got a a a I'm guessing
Yeah,
an aspiring data scientist here by the name of Ashit. So Ashit, if you want to jump in at any point, just come in, man. Join the conversation. Don't feel like you got to.
yeah, Ashid, I wanted to know more about you, buddy. Tell us a little bit about yourself. And no pressure, but I'd love you to go on camera if you wouldn't mind.
Hey everybody, how are you
Hey,
doing?
good man. How are you?
I'm doing good. Thanks for having me.
Oh, absolutely, man. You got some legends of data science in the room right now. You've got Dr. Thom Ives, the Godfather, and the king of all things data engineering and data science, the one and only David Knickerbocker. Man, this is if I was in your shoes right now, I would be super excited. I am actually super excited right now. So yeah, man, how can we help you?
I'm excited to be here today because it's been a long past 7 to 8 months. I am learning data science, and that during COVID times I have learned a lot. And at that point, I'm a bit struggling to get jobs. So maybe there is a lot of legends is there. So I get to know, how I can prepare for a job and for job interviews upcoming days, and what are technology I should learn more. So yeah, I'm ready for learning. I'm keep learning new technologies.
Yeah, most definitely. So I'll chime in a little bit, and then I'll let Tom and David chime in. I'm just curious about where you're currently based out of.
Right now, I live in India, Bangalore.
Okay. Yeah, I'm not too familiar with what the job market is like out there, but I can kind of say universally speaking, like learning is great, continue to learn, but at some point you need to apply what you are learning in the form of a project because you need to get that hands-on experience, right? So if you have not yet embarked on the journey for creating a project, that needs to happen as soon as possible. What do you guys think? I'll let Dave chime in because I'll just say hello just so I could hear the sound of his voice. I've never heard him speak before. Dave, how you doing, man? You're muted. We can see your lips move but not hear you.
You're muted, yeah.
All right, how about now? We good?
Yeah, good.
Yeah.
Good.
Sorry about that. I haven't used this laptop in a little while.
No worries.
Yeah, I took a very indirect approach to data science, but I think that we've all, if you've been around data, you've kind of been doing it forever because, you know, if you're collecting data, you want to know what's in it. So you learn SQL and things like that. But I want to come back to the idea of personal projects. One thing that I always tell people, and I've said for 20 years, um, since my web development days 20 years ago, was that you need to find something that you're actually interested in building. Because if you're, and this is one thing that really bothers me about when I was in college classes and things, you know, they would teach you like a C++ class and you'd have to make a calculator. Like nobody cares about making a calculator. That's like just a boring thing to do, you know. I teach my daughters programming as well, and they're very young. I start them when they're 6. And so I taught them things like Mad Libs, you know, so like variable substitution is going to be a part of designing like a Mad Lib application. And so my daughters, when they're very young, they get to see the output and they just laugh and laugh and laugh. And so it's really funny, you know, and it's much more enjoyable than creating a calculator. And it's just showing that you can create a if statement, you know. And then for my own personal projects, I find things that I'm fascinated with. And so in the previous podcast I was on, it was mentioned that, you know, I'm big into literature. Like I do a lot of network analysis. I use NLP to break down books like Animal Farm or Alice in Wonderland or whatever I want into networks, you know, using part of speech tagging. And so at the end of that, you know, you've got this little piece of automation that can rip through a book and create a network of all the main characters and places in a second. Shift enter and it's done. And so to me, that's amazing. And it's almost like in uh, it's almost like a version of the Cliff Notes from old college days that you can actually interrogate and look closer and see relationships between things. Like, do the pigs only talk to the pigs, or do they talk to the dogs? Or, you know, like there's interesting relationships in that. And I've also used this. I posted yesterday at 100 Days of Networks that I've been collecting Twitter data for my area where I live, and I've just kind of let it run in the background on my AWS server collecting data over time. And I've kind of picked up a little who's who in my neighborhood just by doing that automatically, just off of tagging and stuff like that. So if you are not interested in the thing that you're building, then you need to find something that you're interested in building. And so there's no right or wrong thing that you should be building. It doesn't have to be serious. You don't have to chase the important problems of the day. The important thing is to just start taking data and get comfortable playing with it and get comfortable looking for insights out of it. So
Yeah.
you're not
Absolutely.
going to know everything from, yeah, you're not going to know everything from day one, and don't even try, you know, just start somewhere and run. And that's all you can do.
Yeah, you have to be driven by your own curiosity. One of my idols, Naval Ravikant, posted this just about an hour ago on Twitter. If you aren't curious about it, you'll never be good at it. And I 100% agree with that. You have to be driven by your own curiosity, right? So I know deep down inside of you, Ashay, there's something that you find inherently interesting, something that, some question that you just want to answer, right? And from my perspective as a hiring manager, it doesn't matter to me what data set you use. It doesn't matter to me which algorithm you use to solve the problem. None of that really matters to me. Here's what does matter is the problem statement, the question you're trying to answer. Are you, because if you're interested in it, you're going to put in some effort and it is going to show throughout your entire project and it's really going to wow me. Tom, I'd love to hear what you
I loved what y'all were saying, but I do have something maybe a little unique to add, and it's this: is I try to think back about, just go back at least a few laps around the sun and remember, oh shoot, what did I feel like when I was getting started? And you're going to feel overwhelmed many times. And I just encourage you, Ashit, to take a deep breath and remember this is an ultrathon. It's actually more than an ultrathon. And when you feel like your brain's getting fried, take a break and then come back at it and just keep digging. When you finally reach that point of understanding that was a real stickler for you, a real sticking point, really hard to get to, you're going to be so thrilled that you took the time to master it and figure out. And really, the other thing I find is super valuable, we've got to remember, well, this happens both directions. Math is both a gateway to mastering concepts, like from the math, but a lot of times what we see in the art of data science, right, Harpreet, is that we have to start with the concepts and use mathematical conveniences to serve those. So don't get stuck looking at everything one way. Keep reading extra references, keep looking at it from different perspectives. And when you get over that conceptual hump and you reach that level of enlightenment on a principle, you're going to be so glad you did it, and then you're going to want to rest up and do it again. So,
Yeah.
But we work in, even if you didn't have to occasionally work with difficult situations and difficult people, just what we deal with is difficult. So don't let it ever get you down. Just take a break and get back to it. You'll be so glad you did it.
We got Carlos Mercado in here too, dude. Like you are like you got all like the best people from LinkedIn in one room with you to help you out. This is pretty amazing. So Carlos, here's Ashit's situation. He's been learning up on data science for the last like 7 to 8 months, and he's just wondering, what is it that I should learn next? I can't get a job. Do I need to learn more? We're trying to convince.
You know my answer, man. My answer
Yeah.
to me, start at the bottom. Just get like a basic business analyst job. And guess what? If the job description just says Excel, show up, do the Excel, and in the back end, do it in R or Python. Like, just go into something that's paid, because you have to get paid to learn. Like, the longer you're learning unpaid, like it's you're not gonna outlearn the cost and like long-term net, net profit, whatever, net value, what's that called? Net present value. Yeah, you're not gonna beat the net present value of like doing it while getting paid to do it. So yeah, I would say like lower the job role expectations and just get into something. Obviously, your first job matters a lot. Every job matters because you don't want to leave a job after 3 months. That looks bad. All that stuff. It's all good things. But like right now, 7 months, man, that's too long.
Real quick, I got to say something. I've never gotten to talk with David or Carlos, but I know you both. And I just want to say, I love the way you're contributing on LinkedIn. Carlos, I've been eager to have a chance to get to know you because I love what you're feeding people about getting a job and gaining the experience. And I want to leverage off something Carlos was just saying. My blog author team and I are about to release a new post because we were concerned about just this sort of thing. And it kind of comes back to the basic high-level wisdom of be, do, have. Don't think you've got to have in order to do, in order to be. Become a data scientist. Don't worry about whether anyone's giving you that title or not. Then look for every opportunity you have to do data science. And then eventually, Ashit, you will have the recognition of being a data scientist, regardless of what your job title is. And Carlos, he's always just really cutting to the chase in his LinkedIn post about what's important on your resume and your work and your attitude towards being and becoming a data scientist. So I hope you're connected to all of us, but especially Carlos, you can tell he really cares about helping the new guys get into the field and the right attitude about getting into it. So can't say that enough.
Yeah, that's
Thanks,
awesome.
Thomas. I appreciate it.
That's excellent advice as well.
I
Like
feel
you don't go for it, man. Go for it.
I just feel like I'm goofing off on LinkedIn, man. I'm always just like straight
No.
goofing. Like I'm just saying crazy stuff. I'm just like, oh, I'm like The thing is, my job is so much like there's so much business fluff in consulting. It's just like fluff it up, fluff it up, fluff it up this proposal, fluff up your resume, and I just can't stand it. So I get really good at doing the fluffing up, and then when I get fluff back, I have to like, okay, well, I need you to unconsulting this for me, please. So I just do it to everyone's resume now all the time. I'm just like, oh yeah, this is me. I did a resume review I just did for this guy. He had 2 pages, and I posted about it on LinkedIn, and like he called himself a machine learning expert. He had his master's degree, but he had no relevant experience, and he just like it was so misaligned. Like he would have 8 bullet points about his depth of experience in data engineering, and I checked out his GitHub. I went to every single repo on his entire GitHub and every single notebook and every single file just because I wanted to make sure that I didn't say this rudely. I was like, you've never engineered anything based on my read of your GitHub, and that's okay. Like, just tell me you got the CSV and you did this for this reason, and tell me like why you chose to do the things you chose to do. Don't like tell me that you're doing data engineering stuff, man. Like that's like you're gonna get caught by someone who's not nice.
Yeah.
Anyway,
it's hilarious. I'll read one of Carlos's posts and I'll go, damn, I need to go fix my resume now. And it's an old resume, trust me. A lot of years on it.
Yeah, that's so much good advice for you there, actually. So to kind of piggyback what Thom and Carlos are saying, like, you don't need to be a data scientist to get data science experience. I know Carlos has talked about how he just gave a little bit of his experience. He had a job that was primarily using Excels. He said, screw it, I'm doing everything in R Shiny, and he did it. From my experience, when I was a biostatistician, clinical trial statistician, I was one for several years. There was no opportunity for me to use any open source software. But what did I do? I recreated the work that I had to submit using SAS in Python, because now I had I guess a baseline line of sand to compare it with. Right now I had an output that I could work towards. So I think the biggest takeaway you could take from everything that everyone here has said is, first of all, if you are hurting for a job, just get anything that is data related, data adjacent, right? Even if that means becoming a business analyst, don't go for the title right now. Just go for roles and responsibilities that are aligned and are going to take you to where you want to be. While you are on that job, there's nothing precluding you from using the tools that you want to use, using the methodologies that you want to use to get the job done. But if there aren't opportunities for that in your current role, then you also have the option of waking up early every morning and doing a personal project that will get you the experience that you need. Right?
Hey, I want to shout out to someone that's not here real quick.
Yeah.
I'm a Python guy, but I am definitely not an anti-R guy, and I want to make that clear. But I love it the way David Langer does things on LinkedIn, and I've been really trying to support his posts on, hey, Excel is still valuable. What we're getting at, Ashit, it's a big toolkit. And over time, when I first started woodworking, I sucked at using a table saw. Now, I challenge anyone to use a table saw smarter than me, but it took years to kind of, oh, that's right. That's why that sucked when I cut that way. And it's like spreadsheets, awesome tools. I was teaching my kids to do, because of their math book, linear regression problems in a spreadsheet. I mean, they have those functions in there now, but, spreadsheets have their place, but they're not R, and they're not Python. And so you just kind of get good over time to think, oh, I just really need to kind of see something conceptually. And before I even start prototyping, spreadsheets perfect. Want to get a little more productive, more automated, spreadsheets suck. So just nothing's bad. It just has its place. Sorry, that was a little longer than I meant.
No, that's great, man. Wonderful. So toss it back to you, Ashit. If you got any questions, go for it.
You're on mute, in case you didn't know, Ashit.
Yeah, in case you are. If you're talking, we are unable to hear you because you are on mute.
You might have had to step away, I wonder.
Yeah.
David, were you going to say something? I saw you put your hand up.
Yeah, go for it, David. Yeah.
And I work in security, and so I see multiple sides to this, because every couple of years there's a brand new hype. 2015 it was big data. 2016 it was DevOps. Whenever it was, data science became the thing, and then it became ML/AI. And so it's constantly there's some new thing to chase, and there's always going to be a new batch of graduates. And I was the same way 20 years ago, so it's not a knock or anything. But there's always going to be people in college that are taught that this is the hot thing. You're going to make a ton of money if you get out of school and you do this, you know. And so I often run into people before that were chasing security because that's where the prestige was at the moment. And now it's ML and AI and things like that. And so my recommendation is really not to chase titles at all. To be honest, I don't even know what my title is right now anymore. I just got moved to a new team. I do more platform engineering, but I'm solid at modeling too. So I can do a whole lot of things, and that comes from I've a long background forever. And so I don't know what my title is, but I get to work on really cool stuff. I get to work with data scientists. I get to work with engineers. I get to work with data engineers. And we get to build stuff that's just amazing. And so don't worry about the title that much. And I really like the idea that don't feel like you have to become a data scientist for your first job. You know, it's going to be security as your first job. There's a lot of experience that goes into.
Hang on, David. We're getting some kind of horrible feedback. Okay, everyone is muted.
What the? How about now? Good. All right. So I was just saying, don't necessarily chase the hot job title at the time. Even by the time you get there, it might not even be the hot job title. And so look for just your way in. And so for me, you know, I got into web development in 2000 because I found that to be extremely exciting. And at the time, all websites were static, except for like Yahoo, you know. And I lived on a tiny little tropical island where there were no web developers. And I saw people putting cars for sale on a thumbtack board, and I was like, this is ridiculous. And so one day I stayed at work late, and we had a website and it had MySQL, and so I stood up a classifieds website, and it was an immediate success because it was just needed. And you know, that gave me access to the database, that gave me access into what users were actually doing, that got me into SQL, that got me investigating behavior. And you know, 20 years later, like that got me into data science. And so, but there's a long progression, and you don't learn everything all at once. You're not going to learn SQL on day one at the same time as you're going to learn everything about security at the same time as you're going to learn DevOps. It's very overwhelming for a beginner. So like these guys have been saying, just try to find your way in. You're going to make decent money so you can survive anyway. And it's going to be much less of a weight than trying to chase the ultimate prestige on your first job. That's going to be nearly impossible. But, you know, it does happen. So give it a shot if you feel like it. But getting in is more important.
Yeah, I'd also just add that, like, if you are looking for a skill to practice, make sure you're balancing the technical ones with the soft ones. Like, what really set me up for success on my first kind of data job was not the data stuff. I mean, my first job, I told Harpreet this probably 10 times, was copy pasting out of Microsoft Word into Notepad to strip formatting, cutting it again, and then pasting it into Adobe Captivate to make e-learning courses. And my break there was understanding that this is text data, and it's in this unstructured format of Microsoft Word document, doing the change management to get everyone to align to these templates, doing all the change management communication to say, hey, if you all will just follow my instructions, we'll all be able to do all 1,000 of these things in the 6 months we have. And just like doing the actual culture and communication and leadership of like, let's make this a process, let's formalize these things. And I would not have been able to do that if I was younger, if I was fresh out of college in that job, because I would have just kept quiet. I would have just done what they told me to do, and I would have never pushed on like, hey, let's bring science to this, even though this data is not what you think of as data. So definitely like make sure you're practicing like the conversation, influencing people, just the confidence, like, okay, this is my third day, and I'm like, hey, can we do everything completely differently? And they said yes. It was my third day, because I knew that if I did a third day of 8 hours of copy pasting, I would have quit that job and lost my apartment. So I mean, like you have to like kind of take advantage of situations where you're new, because everyone's like, they don't know you, so they don't have any conceptions about how outspoken you are, and you got to like leverage those chances to be like, to say whatever's on your mind, like, oh, this is all stupid, let's start from scratch and rebuild everything. And that's how you end up on people's radars, like, oh, this guy just came in and destroyed everything and built it up better. Do we have any other projects you can do that to? And that's how I got invited to do the hospital improvement network automation work and the statistical analysis of like which facilities need to be modernized over others. Like I was doing math for the first 6 months.
That is good advice. I like that bit about just speaking your mind, because I see a lot of people who get into the field and they are afraid to speak up because they're afraid to quote unquote look stupid. They are afraid to be
Someone's gonna
wrong,
think you're
to make a
stupid always.
mistake,
Like
right? Yeah.
someone's gonna think you're smart, someone's gonna think you're stupid. You can't wear it. Like you're gonna make someone mad and someone super glad doing the same exact thing.
Yeah, exactly, right. As long as you're living by, I guess, your principles. David, you look like you got a good story to share with us here.
No, I'm just saying in engineering, you're going to meet a lot of people that are as smart or smarter than you, or pretend to be. And so you're going to run into difficult people. Like there's just no way around that, And so you have to build your confidence, because if you're the voice of reason, you have to be more confident than the people that are the voice of emotion, And so if you have to pick your battles, make sure you come equipped with data. And so you're bulletproof if you do, nearly, unless they bring better data, and then you both learn. So yeah, I really liked what Carlos said, because no matter what, every single time somebody's going to think you're wrong. I just joined a new team, and I'm trying very careful to not come in just swinging and saying everything is wrong from the very beginning, and I was asked to give some pros and cons of different approaches. And I replied that, I like to ask questions that kind of probe the areas before I say that they're wrong, and so there's ways to be tactful while at the same time shining a light on a potentially problematic area. And so diplomacy is very good to practice. Learning how to say cutting things without hurting people is very important. Build allies, know who your people are. Like you have to do more than just be smart and aggressive. You have to be somebody that people want to work with. So
I got a one word. You guys will love the parsimony of this model. And the reason I like to preach this is because I sucked at it so badly in a lot of parts of my career. It's a 4-letter word. Sorry for using a 4-letter word. It's care. CARE.
I was gonna say empathy, but that's pretty much the same thing. Yeah.
And here's what I mean, Ashit. If you care about the business and the people and their tasks, you'll go get to know them and say, what are your big problems? And then you're going to look for an intersection of where your data skills, where you're currently at, because you can't change where you're currently at instantly. It's going to take time, but there's something you can do now, because if you care and want to serve your counterparts in the business, you'll find a way to help them with data. And that gets you a little bit of clout. And then you keep trying. Even if you fail a couple of times, just keep trying to find a way to say, I care, and I'm trying to bring some value with data to you. Now, I don't disagree with the people on LinkedIn that make a big deal about developing business acumen, but I'm like, you could have business acumen equal to the person you're talking to, but they may not recognize it or think that you do. But if you show them you care and you're really trying to solve one of their problems, now that's going to get their attention. And then they might, after you bring them several solutions, they might start to ask, hey, Ashit, what do you think we should do here?
That's so crazy, because I'm writing a blog post, and it's very heavily centered around this type of conversation we're having right now. And it's a framework for persuasion, not like that slimy, greasy persuasion, but persuasion as in trying to get people to buy into your ideas. And I call it an epic framework. EPIC: empathy, perspective taking, influence, and concurrence, right? So these things put together, you can be able to get buy-in for your ideas. Because believe it or not, as a data scientist, you've signed up for a career in sales, whether you like it or not.
Yes. I'm so glad. I'm glad it's starting to happen. People are seeing that, like, oh, most people don't really want to do things the scientific way because it's so much structure and so annoying. I just want to be like data informed. I don't want to be data driven. And like if you're gonna, you got to convince them to stop being informed and be driven. Like it's hard. It's hard to say, hey, make all the decisions now, make all the possible decisions now, and then whatever the data says, we're going to commit to that direction. We're going to take, if it's 0.5, we're taking a left. If it's not 0.5, we're taking a right. But it was 0.49, Carlos. It's like, no. We made our lines in the sand. And it's hard to do that. It's hard to like get everyone on board with that. And I have failed plenty of times. I've gotten destroyed for like trying to force people into spots I don't want to be in. And then you have to learn to be like, okay, what's the best I can do? The best I can do is give them the right number and let them be fuzzy with it later. Like you're going to lose some battles, but just try to be scientific. Oh, it's happening. We all just like spammed on LinkedIn. Hey, come join us. And now it's like everyone's in. I'm super. Oh, look, it's Eric. What's up?
Yeah, Eric, friend of the show. Oh, nice background, Eric.
Hey, how's it going?
Good, man. Thanks for joining. So, Ashith, we probably answered questions that you did not even think of asking. So hopefully you got what you need, man. If you have any other questions, feel free to ask. Eric, man, nice to have you here. Let's go to Harpreet first. Harpreet has a question, it's almost like my name, but without an H. Interesting.
Oh. Hey, no, I just joined in to listen.
All right, man. Well, happy to have you here, dude. If you got questions or comments or whatever, man, just join in on the conversation. Eric, man, how you doing?
I'm doing well. Crazy, up to my eyeballs in survival analysis stuff this week, so that's cool.
Oh, nice.
But it's great. I actually really enjoy it a lot, so I'm definitely enjoying it. I did have a little bit of a question I was working on this morning. I was curious, I was thinking about like, so we're also doing like XGBoost stuff and random forests and things like that in class. How do those deal with two things? One, rare events, and two, like, how can I like weight something so that, like if a negative test is more significant than if a false negative costs me more than a false positive, how do I weight that appropriately to take that into account in the algorithm, or can I do that?
I'll let Rose go first.
Yeah, it's going to require me to think a little bit on that one.
At a generic level, you should be thinking about how you balance unbalanced data sets probably before you do modeling, because there are lots of ways you can, like, what is it called, bagging? Is that the word? You like replicate them up. Mm-hmm. There's also cutting your sample down. Like you can upsample your low, or you can downsample your high. Yeah, and those will have pretty big differences in terms of what their outputs are. Like you will get different confidence intervals, you will get different coefficients sometimes. So you do want to play around with what makes more sense for you. I generally recommend upsampling. Just if I have no information at all, that's what I would recommend.
So a while back, a younger data scientist reached out to me thinking I was the master of all things. And it was very much a question like this, Eric. And I said to him quite artfully, I have no clue, but when you figure it out, will you check back with me and let me know what you came up with? And he was thinking, maybe I need a GAN. I said, oh, I don't think you want to go down that route. That would be really hard. That would be harder than your original problem. And he came back and he told me about SMOTE, SMOTE, very powerful technique. And then the next time someone asked me, I was like, well, have you tried SMOTE? And frankly, Eric, I've never used SMOTE. I've never had to, because most of my problems aren't of that nature, but it's helped several people now that I found out about it.
Cool. Yeah, I did see that come up as I was kind of like doing a little bit of research. Just hadn't gotten all the way down the Google listings of everything. And I was looking at, it looks like in sklearn there might be a parameter for weighting things, but that wouldn't necessarily deal with the rarer events or imbalanced data.
What's your use case, like, so you have imbalanced data. Is that what you mean by rare events? Like, talk to us more about the use case that you got going on?
Yeah, so that's actually, so I'm working, it's just an assignment. And unfortunately, I don't have a lot of context around it, which is kind of killing me. But I do know that false, I have to go back and check, false positives cost significantly more than false negatives. And there are a lot fewer. It's not like rare event is in like less than 5%, but there are definitely a lot fewer positives than there are negatives.
I just want a caution here. I think whether a false positive or a false negative is worse kind of depends on each specific situation, right?
Yeah, and this is like stated specifically in the prompt.
But it also matters how much more. Like a false positive in a cancer diagnosis can lead someone down a path of actually getting cancer from doing risky. So like the numbers matter when you're doing that. But also, again, just generically speaking, if you're doing like logistic regression, for example, you would balance your false positives, false negatives by altering your threshold for your binary classification. So that's when you get into like, okay, let me look at my F1, let me look at my precision, my recall, and then you could actually, this is where you get in like weird hyperparameter stuff of like, you set your threshold based on some loss function of the cost of false positives and cost of false negatives. But you end up like way deeper than you really want to go, because then you're like tuning hyperparameters while also tuning like the weighting of your balancing of your data set. Like you can get down a real rabbit hole really quickly.
But I think that that's probably kind of the direction you want to go, right? So if you're worried about false positive, false negatives, then I don't think that is a modeling decision. I think that is an evaluation criterion that you need to concern yourself with, right? And then assess your quality of your model based on that. But like, I could possibly be wrong. Like that's a very real possibility.
No, that's a fair point. You're right. You should choose. Thing is, you can't, like, this always happens. You can't throw the kitchen sink at a problem. Like you're supposed to look at the problem, make assumptions about the fundamental data generation process, and then pick models that you think align to how that data would have. There's supposed to be a causal thing in your head. Even if you're not doing causal research, you should have a cause in your head. And like a lot of data science, we like forget that. So we'll just be like, okay, here's like all these models. Let's throw it at it. And it ends up happening like completely uninterpretable coefficients and stuff. So I don't know.
Yeah,
Again, you're doing an assignment, but
there's a lot to be said for what they're saying. I mean, it's not that I hate hyperparameters, but if I start having to really stress over tuning them, I'm thinking, I'm maybe going down a rabbit hole here. And something that I found brilliant, and I learned from the very sophisticated learning platform called Khan Academy, it's super helpful to just draw a simple Bayesian tree on these classification things to help people get a feel for, well, this is high accuracy, but what's it really mean? And you start to get a better feel for, oh, just because it's 98% accuracy or 2% find rate, looking at that Bayesian tree puts it in a much more clear perspective about the value of this model. And I would be hard pressed to get into the details of it, but if you just go look at creating a little tree that defines the way your results are falling out. I'm not doing a good job of explaining this, but it's super helpful, super clarifying.
Cool.
Since we're on the topic of hyperparameter tuning, I like to define my hyperparameter search space as a function of my input data set. And search within that space. And by function of it, I mean define it by the range of it by number of columns, number of rows, and different functions of those. But yeah, David.
Can you give us an applied example of that? If you have a small one in your head, I just know it's gonna go. That sentence is gonna go over a lot of people's heads. So if you could give us an example version.
Like for example, number of trees in random forest. Like instead of just picking 10, 100, 2,000, a million, right? I will pick a number that is maybe ranges from minimum 2, right? Because you can't really have a random forest without less than 2 trees, up to maybe the log of the number of rows, and search in that space, right? So it becomes, you know, your input data set, have that define the bounds of your search space.
That's a really good example, and it's really important because you do not want to end up doing arbitrary stuff like 100 net sounds good. Like you really need to, like most people need to like get out of that habit. Even with like funny stuff like setting seeds. Me and Adrian got into the whole thing on LinkedIn. He was like, "Oh yeah, seeds are hyperparameters. I changed my seeds to get better random stuff." And I'm like, I've never heard of that. It's never crossed my mind to play with seeds. I pick 4 because it's just my favorite number.
I do 42.
Like yeah, I feel like I didn't realize this, but apparently like there are legitimate issues with different seed sizes and how they affect like distributions of like, and obviously they do, but like I didn't realize how much it can matter. So
yeah, there's like
it's a
research
good
papers.
point you're making. Like don't be arbitrary and pick 100. Like I like that log of your n rows.
So question about the seed thing though, like couldn't that be like seed hacking, where it's like, this isn't significant. Let's try seed 124. Let's try seed 125. You know,
I called it seed hacking, and some people cleared me up that it's not hacking. I still think it's seed hacking personally.
Seed hacking,
but it's not technically seed hacking.
One thought for you guys, so my modeling background's kind of wide, and there's been many times where I had to search a parameter space. And one thing that occurred to me that I really am eager to put into my automated pipeline framework is, this was a super helpful point. I can't remember where I came across it, but you typically want to change these hyperparameters on a log scale. And it occurred to me that, if all of my hyperparameters have let's say you're doing a search routine, but it's always 3 log values. And if it hits the maximum on any one of those, that becomes the new midpoint, and you put one before and one after. And when all your hyperparameters end up on a midpoint, if you want, then you could even bring down the scale tighter and look again. But I'd say if you just hit the midpoint on all your log scales by going at it that way, that's a really super fast way to zoom in on a pretty good set of hyperparameters in an automated fashion.
So I like to just kind of loop through the different parameters I'm looking through. So if this is random forest, I'm looking for max features, max depth. I mean, you can really just throw a double loop in there. And I try to spit out as many metrics as I can, including the confusion matrix, including the summaries, because they're going to behave a little bit differently, and you want to be able to track that as you go through that. And so it's just aiming for maximum accuracy is not going to give you what you want. I mean, you might sacrifice something towards that. So I don't feel like I always feel kind of a misfit when I'm around data scientists, because I approach things more from an engineering or automation approach, not the most elegant solution. I kind of brute force my way through things, but it does work, And so I just try to collect as much information about whatever it is that I'm doing and record it. And so I tell people to apply data science to data science, track what it is that you're doing, track your improvements, make sure that you're going in the right direction. And so this is kind of my approach, and it works for me. So
if it's not too slow, brute force can be our friend.
Yeah, definitely.
To the point of experimentation, man, I just started messing around with ML flow. Before that, I used to have to manually track my experiments, which was messy. But ML flow has been super nice. Eric, hopefully we answered your question and didn't just dance around it. And
no, that was great. I knew I was coming in here with something vague anyway, but I really appreciate getting. I definitely got more than I bargained for, so that's good. Right, I will throw out to try and contribute something small. I've been doing this stuff in R, and the Ranger package has been awesome for just the hyperparameter tuning and grid search and all of that, and just tracking it all. It's been really helpful. So Ranger package.
Nice. I wonder if
hey, Eric,
Python
equivalent. Really love your posts on LinkedIn. You're a great contributor. Wanted to give you a shout out
thanks.
for that.
Trying to say something for, I mean, that was just something that I noticed is just I want to even though I'm a student, because there are so many people who are students like me and feeling like, well, I don't really have anything to say. It's like, sure, you have something to say. Like everybody has something to say and something to offer. And, so
I'll
I
give you a
appreciate that.
cool story. I can't remember whose show. John Thompson. Oh yeah, he was on Robert's show, and they saw Tina Mary's name scrolled past. Now John Thompson, he's the real Godfather, Harpreet. Anyway,
I'm interviewing him on Monday.
Oh, awesome! That is so. I will not miss that one. But here's my point. Tina's in her master's program, but she has a passion to just give back to the community, make things really clear that she's learning. John Thompson took note of her post, and he called her out on the show while he saw her name and said,
Wow.
Tina, you do great posts on LinkedIn. Shoot, if Tina, you and Tina to me are on equal level of, wanting to give, wanting to share what you're learning, just share the passion. It's awesome.
Thanks, Tom. I really appreciate that.
Yeah, man. Keep it up, man. Keep up that good work, man. Appreciate all the contributions making. We got Christian in the house, man. How are you doing, my man?
Hey guys, glad to be here. I've been thinking about jumping on one of these for a while.
Oh, dude.
And,
super happy
glad
you
to
made
make
it.
this. I saw the All-Star cast and I had to jump in and listen.
Oh, man, dude. I'm super happy you're here.
Appreciate that.
So where's everybody based out of, man? So you sound like you might be in Texas, and Tom's in Texas too, maybe. I'm not sure.
That's right. I'm a Houston boy.
Nice.
I was born and raised in Dallas, but I'm living in Idaho now.
How's that? You like the transition? I know the biggest thing around. Well, Dallas isn't too bad. Houston is just crappy all year round when it comes to weather and all that good stuff.
Christian, I hope I won't offend you when I say this, but when I was a young man, I sincerely prayed, God, I'm really willing to go anywhere in the world you want me, but please don't send me to Houston. And I really meant it. But I don't mean that like I hate Houstonians. I just really did not want to live in Houston.
Anybody from Houston understands what you mean. No offense taken.
Drake always talks about Houston. I thought it was like a wonderful, magical place.
It's got a lot of good things going for it. But
it's
the weather's not one of them.
Can't handle the heat.
Oh, yeah, dude, neither can I. That's why I left Sacramento. That's why I'm in Winnipeg, where it's, as of right now, -2 degrees Celsius. With the wind chill, -20.
Wow.
David, where are you? You're Pac Northwest, right?
Yeah, I'm in Oregon. I actually grew up in Japan, and then I moved to Seattle like 7 years ago. And so I don't really feel like I fit in the States because I grew up outside of the States. But it's cool to be here.
Dude, Oregon is so nice, dude. Like
it is. It's breathtaking, and I love going to Portland. And we've got this massive bookstore called Powell's that is just destroys my wallet every time I go there. I walk out with like $100, $200 worth of books. Like that's just the worst place for me. And then right next to that is my favorite restaurant where I'll go blow another couple $100, on wild salmon or something.
Some good beer in Portland as well.
Oh my God. Yep. Yeah. This is great.
Carlos, he's out in DC. Eric, where are you at?
I am in Durham, North Carolina.
Oh,
Been here for about a year and a half, though. I'm originally from Salt Lake City, and then my wife and I decided to jump in our motorhome and take a year and drive around, do freelance stuff. And so we went up through, I guess, David's neck of the woods, came down the coast and across the south, and kind of finger on the map landed here. And we love it, so it's great.
You're at NC State, right?
Yeah. I'm doing my the Masters of Analytics program at NC State.
You're gonna be my coworker soon. That's our #1 program, man.
Yeah?
A solid third of our team is from NC State.
Oh, wow, that's cool.
They were the first ones who were like, hey, we're a tiny data science group. Can we interview your students? Like, yeah, we want all our students to do multiple interviews. And we just send like a van of directors to interview from there.
Yeah, I knew that. So Guidehouse was actually supposed to come recently, but they're like, oh yeah, we can't make it because we got like elections stuff we're taking care of, and so we had to postpone it. And so I'm super excited for whenever y'all are able to come by and talk, because that's a super interesting topic to me.
It was a headache because with COVID-19, like it was our DC headquarters that would go to North Carolina. So like we got to do all the state travel and everything. We don't have like a group that's nearby. We just like the school and drive the hundreds of miles.
Cool.
Arpit, where are you from? I know Ashit is from Bangalore. He's joining us in. It's probably like 3 a.m. over there for you in India. Damn. Thanks for joining in, man.
Yeah, it's 4 a.m. right now.
Where?
4 a.m.
Oh shit. That's what time I
No,
usually
it's
wake
okay.
up.
Actually, I work for night shift, so I just 1 hour, half an hour before I just finish my work. So
Nice.
yeah, that's actually regular time for me. Actually, I work for that back office for AT&T. So yeah, so we have to deal with a lot of reports, Excel reports every day.
Man, that's rough. Like I wake up at 4 a.m. I can't imagine staying up that late. Arpit, where are you joining in from? Oh, we got.
I live in San Antonio, Texas.
Look at all these Texans, man. Look at all these people from the South out
I
here.
used to
That's
live in
awesome.
Boston. I was in
Boston.
Boston, and I moved there like 2 years ago.
Nice. We got Karan in the house. Karan, thank you for joining. Man, this is awesome. We need more representation here, though, man. We need more women from data science in these chats contributing their viewpoints, man. So if any of you are listening, please, you are welcome into the open office hours. Come and join.
I gotta get some more of my coworkers to join too. We just don't plan it out, and the calendar invite doesn't open our calendar right, so we all forget. It's not like a isolated calendar. Anyway.
Yeah.
Yeah, we do gotta up the representation. I think it's important.
Yeah, last week.
Did you go to the Dedicated Academy or Dedicated conference?
Yeah, I joined in for a couple of those sessions. It was nice.
That had great representation, so I bring it up.
Yeah. Last week, Nicole Bills joined in, so that was pretty cool. Yeah.
Hey, hi, this is Karan.
Yay, hey, how's it going, man? Hey.
Good. How are you guys?
Oh, good, man. Just hanging out, shooting the breeze, man.
Sure. Yeah.
Yeah, dude. I was supposed to interview Chase Caprio from Impact Theory at 5 p.m., but he was having issues with his connectivity, so we had to reschedule to Wednesday. Really looking forward to that, man. He's a real cool guy, and he works at like my dream company for my dream boss. Tom Bilyeu is one of my idols, man. I really look up to that guy, so really looking forward to that opportunity. So yeah, if anybody got a question, man, Karan, Christian, Arpit.
Yeah, Harpreet, I have one question. So I keep reading about this, like correlation is not causation, like it's everywhere. Like, so how to make sure if I'm seeing some correlation in between two features, like how to make sure there's causation also?
I would start with common sense at first, right? There is a correlation between the consumption of ice cream and drowning deaths. There's 100% there's a correlation. I mean, I don't mean the correlation is 100%, but as ice cream consumption tends to rise, and as outdoor ice cream consumption tends to rise, so do drowning deaths. Does ice cream consumption lead to drowning deaths? Likely not, right? So that is a clear example of how two things can be correlated, but one does not cause the other.
Unless our data set is already people actively swimming, in which case eating ice cream might use one of their hands in their drown. It's always context.
Yes, context. So yeah, that's a very important point, right? So context is very, very important.
Okay. So basically, business knowledge, like if more business domain knowledge, then you will be better.
Yeah,
you can better judge that.
Yeah, I mean, just kind of being able to tease the two apart, like just using a little bit of like you mentioned, domain knowledge or common sense, and applying that to the situation. But I'd love to hear what Tom, David, or even Paul. Paul, thank you for joining in, man. Nice to have you here. Correlation does not equal causation, but how do we tell when correlation does imply causation?
I like the way you put it, Harpreet, but that I noticed that in my studies, and I kind of stunk at this sometimes, quite frankly, that that final step to say this is causation needs to be taken very carefully.
Absolutely.
I'm not sure that's helpful, but be careful.
Yeah, I would just quickly note, are you sure causation matters? It's a lot of problems where nobody cares why. They just need to know if the stock's going to be up tomorrow or not.
Yeah. And I think the important thing is it's like the sentence itself is supposed to make you think about something, right? So you could have some features in the data set that are definitely correlated, right? But you should stop and think about, okay, does this imply that one causes the other, right? So you should think of that correlation does not imply causation more as a warning for you. Like, okay, cool. Like I see things are correlated, but let me just really think about it and tease apart what I know about the context and situation to see, you know, does it work here? Does it apply here? Right.
Yeah, I like that common sense approach that Carlos gave too. You know, if you've got two features and they're highly correlated, you know, maybe there's leakage, but you know, maybe just think about what they are. You know, step away from it, and if you need to, go for a little walk. Let it try to sink in a little bit.
And maybe I'll retract a little bit too. Is like, so I'm trying to practice more thinking in like business context, right? You have two things that are correlated, and the reason you want to know if they're causal is because, you know, if I raise my salespeople's phone call minimums, will our revenue go up? Well, that's a correlated activity. You want to know if it's causal because you're not sure if you want to force them to make more phone calls because that could take away from their emailing. So I mean, it's a deep question. I would just, you know, if you have control over the business, what you should recommend for them is to do a causal problem. Like, okay, you want to know if raising your phone calls will raise your revenue. Let's get a subsection of your team and raise their sales minimums on phone calls and see how their revenue changes over the course of 6 months. Like, take this correlation and use that as an input into like a specific process. Like, don't try to just make some big decision immediately.
That is an excellent point. And there's really this subset of data science that stands on the border between engineering and data science, and it's called design of experiment. And what Carlos just described could be achieved by design of experiment. That's where you start to see factors in causation. But the cool thing with design of experiments is you can do small changes that don't cause damage. Just you basically experimentally finding factors, and that can reveal causation. I was feeling really bad because my earlier answer, just leveraging off Harpreet, was kind of worthless. But design of experiments is a super powerful way to just determine if it's not obvious if causation is present or not. Design of experiments can be a really powerful revelatory tool.
And that is not just like the random like allocation of people to like randomization control trials, like one method of causation. There's also like, you know, if you're stuck doing the post hoc causal stuff, I'm gonna say do score matching, regression discontinuity. There's like other things that, I mean, I think they're kind of pseudo causal, but they're better than correlation. And you can definitely look into those and like just see what it means. Like, what does it actually mean if you get all your rows and all your cases and you assign them some kind of code that's like, oh, these people are functionally equivalent. So differences in these functionally equivalent groups are going to be how I determine if something's causal or not. Like, you can do some stuff. It's just hard. But I mean, yeah, like those buzzwords will be useful for you if you look into those things.
Get you to think, right? So if you guys don't mind, I'm going to read this little page from this book because I was reading it earlier this week, and it has to do very much with this idea of correlation and causation, right? And this has to do with just the fact that some statistics can be misleading, right? So let's say a study comes out that says that 20% of the time people text and drive. A company trying to sell car insurance might come out with an ad saying 1 in 5 people text while driving. Make sure you have good insurance. Notice the sleight of hand. One statistics tells a story about text messages. About 20% of the time, people are texting and driving. The insurance story is about a group of people. About 20% of all people are doing something. So maybe there are very few drivers who are texting, but they're doing it often, and that influences the data. You might text 20% of the time you're driving, but that doesn't mean that 20% of people are texting and driving. An average person might spend 5% of their day smoking, but that doesn't mean that 5% of people smoke. The story the insurance companies are trying to tell us is about safety. It tries to give us the impression that everyone is distracted by texting. It makes the connection that these text messages are making it more dangerous to drive, right? So it's getting you to think critically about the situation, right? So that is why this buzzword correlation does not imply causation really exists. It's to force you to really think critically about the nature of what it is that you're examining, right?
Kind of along the
Thank you.
lines of thinking critically about correlation and causation, I was thinking earlier this week about COVID-19, right? I mean, kind of comes across my mind every now and then, and
I wonder why.
yeah, right. And so it's so easy now to look at every graph of everything and just be like, oh yeah, that was because of COVID-19. And so for me, as I'm thinking about it, obviously it's impacted by COVID-19. It's really easy to spot, but we do know that there's a domino effect of this thing suffers, which causes this thing to suffer, which causes this next thing to suffer. And so I've been trying to just keep in my mind, I don't want to take the easy way and just blame COVID-19 without necessarily thinking through the whole process, because that totally robs me of perhaps multiple opportunities to find improvements in the process along the way. So anyway, I just trying to keep that in mind when it's related, but not necessarily COVID-19 and now the problem, but there's a lot in between.
This is one thing that I actually like about networks, which is what I've been writing about a lot lately, is because when you actually draw it out that way, you can kind of see what influences what. So you can understand how cascading failure works. And so I don't get to show this to you guys very much on LinkedIn, but I actually do networks all the time at work to map out production systems. And they help me troubleshoot problems in seconds or minutes rather than hours or days. Because, for instance, if an export fails, all I have to do is step back one from that export to see why it failed. And I can often see that one thing for that, I get called one thing for that. And so if you don't understand the hierarchy or what feeds what forever, you really understand, and you'll just start blaming everything on COVID, or you'll start blaming it on the server or something like that. And there's more to it. Maybe the job scheduler broke. So it's
David, is this related to graph theory? I'm really interested in what you're saying.
Yeah, it is. So I do all of this. I do source code analysis. My old-fashioned way was just taking raw production source code and turning it into process diagrams and things like that. But what I found is that that's nearly useless when there's an actual fire to figure out what the problem is. And that if you rather care about what the inputs to code are and what the outputs to code are, that's a network, And so you can actually apply network science to figuring out what the most critical pieces are to a production server, or what's the most critical production server in an entire data center, for instance. Or if you do a network between servers and what product they support, you can get really interesting insights as well. So even today, I was teaching my coworker about this stuff, and it's been drastic. It used to take me, let's say, 30 minutes to do source code analysis on one script, and now I can rip through it in about a minute. So the time savings are massive. I can do source code analysis on an entire server in 2 hours, what used to take me 2 days. And so when you think about how massive that is for figuring out how a data center works, or figuring out a complex server that has 180 programs on it, it's huge, because you can't manage that level of complexity in your head. And so that's why I find networks beautiful, because the networks hold the complexity for you. Does that kind of make sense?
That makes sense to me. I kind of imagining the nodes and edges in my head between function inputs and outputs. This is a kind of dumb question maybe, but is functional programming versus object-oriented programming, does that affect that process when you're doing source code analysis?
You know, I haven't actually run into any functional code in production. So maybe it's because I've been working with people. I worked in operations and I worked with legacy code. And so a lot of it was old fashioned crap written in Perl, you know, and it's just inputs to outputs. And so I haven't actually run into any functional code. I've run into, you know, R, but it was just procedural inputs to that. So the different languages definitely do affect how the network is built. And so if I were to do source code analysis of a stored procedure from SQL, then my method is slightly different because I don't care about what tables get read from and what tables get written to, or what stored procedure calls get called by another stored procedure, or what scheduled job calls the first stored procedure. So there's different tactics, and I will write about this, I promise, because this is massive stuff that has been huge, you know, and I got to present this at my job last year, and you know, people loved it. So it's really cool stuff, but I've only been using it for myself, but I use it for troubleshooting, and I use it for reverse engineering software or re-engineering software. It's just become such a massive part about everything that I do, and the time savings are huge, and the debugging is huge, and like
I'd really love to see you write like a series of posts on LinkedIn, just helping us have a clue how we might be able to apply your philosophy there to things that we face. That it sounds like you're going into a best practices area of something we may tend to do as good troubleshooters or proficient troubleshooters. But it sounds like, again, it's a little cut above than standard troubleshooting, something a little more disciplined, best practices gleaned.
Well, the other thing is that the network really manages the complexity for you. And when you actually visualize the network, you get a very good feel for what that server looks like, feels like. And so like I've got one that I was actually hired to, we call uplift, where you take an old server and you put it on a brand new server. You have to do code changes, change an OS code on a brand new OS, you know. And so managing complexity in my head caused me a lot of anxiety and fatigue. And when I finally finished that, no lie, I couldn't talk for 2 days. Like it was just too much for me. And I wish I understood the network approach, because now I can rip through a server in hours or a day. And I've got a cool visual representation of how it actually looks. I can actually see what nodes are the most important. And I can actually follow data from the point that it lands on the server to the point where it actually turns into some export. And so doing it this way is just massive. And you know, my goal was never really to become a data scientist. I didn't really consider myself a data scientist. I'm just good with data. My goal was to really take data science and apply it to operations. I want to make smart operations. I want production to be I want production to be beautiful. I want it to take care of itself. I want to be able to troubleshoot problems in seconds, you know, and that's really what this is kind of giving me. And so I kind of got all of my beginnings from applying data science and, you know, network science to production, you know, and finding the value that operations people can actually take from it. So,
oh man, I appreciate that. If you got any resources for anybody who wants to read up on that, definitely let me know and I'll add that to the show notes.
Yeah, we might need a small primer on networks and like how that stuff works.
Sure. I promise I will write about this.
Yeah, I'm just doing a bunch of network analysis now with my new client. I just moved, and it's like I forgot all this stuff about graphs and like density and all these things and gravity, whatever. And I'm just like back in it. And I just forgot. Like this is such an interesting domain just to see how like things connect to each other. And when you visualize networks, you're like, wow, like this small thing, if this goes down, 85% of my stuff goes down. And you don't think about it without, I mean, I would love to see a diagram. If you have fake diagrams of that stuff, lucid charts, I would love to see that stuff. Just to wrap my head around on platform level coding.
I might make a network of like the AWS stuff that I built for my own personal projects, because I've got scrapers running in the background and models running in the background, and it's all based off of cron. So it's a little tiny network compared to what I actually see in production for my day job, but it'll do the trick for this. So
So I'm going to open up to Paul. If you got any questions or comments, Paul, be happy to hear you chime in. If not, then I guess we'll wrap up office hours here real soon. We'll be going on for a little over an hour. Paul, if you got questions, comments, feel free to just unmute yourself. You're currently muted, so we are unable to hear you. But yeah, I want to thank Thom, Carlos, David, Eric, Christian, Karan, Ashit, Arpit, and Paul, of course, man. Thank you guys so much for taking time out of the schedule to come hang out today. Makes the office hours lively and interesting. Karan, yes, go for it.
Sorry, I just wanted to mention that it was great hearing from David and Eric. I have been following their posts for a long time now. So yeah, it's nice to interact with them here. Yep. And I think David also mentioned some books recently where, yeah, he had a snapshot of some of the books that he had been referring to. So that was a good reference point. So yeah, thanks.
Yeah, you never know who's going to show up, man. You know, I can't promise that every week it'll be some awesome person here, but I know I will be. So
yeah.
Well, that's why they gotta keep coming. Just come every week. We never miss anybody. I missed like 3 great people. I'm glad I joined today. Thanks for having me.
Last week we had
Definitely, yeah.
we had Sri Watson. Was it last week? 2 weeks ago we had Vin Vashista. So yeah, you never tell who's going to be showing up. Always reaching out to people to see if they want to join in. So hopefully we get some more attendance. Guys, take care. Have a great rest of the weekend. This Monday I've got an episode dropping with Maya Grossman. Maya Grossman wrote the book Invaluable. So she's not a data scientist, but she wrote a book that is amazing. It's phenomenal. It's a great career guide on how to excel in your career. If you don't follow her on LinkedIn already, definitely follow her. Keep an eye out for that interview. I absolutely loved it. I thought it was an amazing interview. Yeah, take care, everybody. Have a good rest of the week.
I'll be the first listener.
Yeah. Cheers, man. You guys.
Thanks for hosting, Harpreet. This is great.
It's absolutely my pleasure, man. And you guys are welcome to come back at any time. These happen every week at the exact same time. Take care, guys. Appreciate it.
Not true. You change the hours sometimes.
Well, yeah, I changed the hours sometimes due to like podcast interviews and stuff. But
follow Harpreet on LinkedIn. He'll post the time.
Yeah,
but it's every Friday.
But yeah, it's usually every Friday around this time. All right, guys. Take care.
Thank you.
Bye.
Bye.